Solving quadratics by finding square roots. We first need to talk about square roots for a little bit. First of all, this symbol right here, the square root sign, is actually called a radical. Okay? You need to get used to calling it a radical because later on we're going to have third roots and fourth roots and so on and so forth. So this is not always just a square root. The number underneath is called the radicand. So we're going to be dealing with the number underneath right now when we talk about these properties. For example, if we have the square root of a times b, that is equal to the square root of a times the square root of b. If we have the square root of a divided by b, that is equal to the square root of a divided by the square root of b. And this is what we do to simplify square roots. So, 18 is equal to 6 times 3, but it's also equal to 9 times 2. Which one of those is a perfect square? That's what we want. 9 is a perfect square, so the square root of 9 times the square root of 2. So the square root of 18 is equal to 3 times the square root of 2. Piece of cake. This one, we're going to split it up. We're going to have the square root of 2 over the square root of 25. Well, what is the square root of 25? It is 5. So the square root of 2 over 5. Here we've got the square root of 27. Well, 27 is 9 times 3. That's it. 9 times 3. So we've got the square root of 9 times the square root of 3. Take the square root of the 9, becomes a 3, and then the other square root of 3 is just along for the ride. So it's 3 times the square root of 3. This one works the property in reverse. Here I've got the square root of 10 times the square root of 15. So I can multiply the 10 and the 15 and put them underneath one radical. What is 10 times 15? It is 150. But does 150 have a perfect square factor? 25. 150 is equal to 25 times 6. Square root of 25 is 5 times the square root of 6. Rationalize the denominator. So we need to know how to multiply and divide radicals. If I have a number 1 over the square root of b. Now b can be any number, whatever it is. To rationalize the denominator, what we're going to do, we're going to multiply by the square root of b. Square root of b divided by the square root of b. Multiply the top and the bottom. So technically, we're multiplying by 1. So we're changing what it looks like. We're not changing the value. When we do this, we get the square root of b over the square root of b squared. What is the square root of b squared? It is just b. We've rationalized the denominator. Okay, so here's another problem. The square root of 6 over 5. Well, this is equal to the square root of 6 over the square root of 5. So what we're going to do is we're going to multiply by the square root of 5 over the square root of 5. Okay, 6 times 5, okay, numbers under radicals can be multiplied by other numbers under radicals. So 6 times 5 is 30, square root of 30, over, well, square root of 5 times 5 is 25. What's the square root of 25? 5. Can you divide the square root of 30 and this 5? No, you cannot. Because numbers under radicals can only be simplified or multiplied and divided by other numbers under radicals. Numbers not under radicals can be multiplied and divided by other numbers not under radicals. We've got the square root of 9 over the square root of 8. Well, what is the square root of 9? Let's simplify this before we do any rationalizing. Square root of 9 is 3. And then the square root of 8. Well, 8 is 4 times 2. Isn't 4 a perfect square? Yes, it is. So 8 is the square root of 4 times the square root of 2. So we do that. We're going to have 3 over 2 square roots of 2. Now, we are going to multiply by only the thing that's underneath the radical. I'm not going to multiply by 2 square roots of 2. I'm going to multiply just by the square root of 2 because it's all multiplication. So, square root of 2 over the square root of 2 equals 3 square roots of 2 over 2 times the square root of 2 times the square root of 2, which is the square root of 4, which is 2. So our final answer is 3 square roots of 2 over 4. Vocabulary. What if we have a number where we're adding a square root, like an integer plus an irrational? Okay, it happens. We're going to see those a lot. A plus the square root of b has what's called a conjugate. The conjugate is a minus the square root of b. The only thing that changes is the plus and the minus. Okay, these two are opposite signs of each other. That's it. So you got to remember, a plus the square root of b and a minus the square root of b are called conjugate pairs. The neat thing about conjugate pairs happens when you multiply them. Okay, if I've got these two numbers and I need to multiply 2 plus the square root of 3 and 2 minus the square root of 3, these two are conjugate pairs. If we multiply them like we multiply any binomials by using FOIL. First, 2 times 2 is 4, minus 2 square roots of 3, plus 2 square roots of 3. You see what's happening? It's minus, because it's a plus and a minus, the square root of 3 times the square root of 3. What is the square root of 3 times the square root of 3? Oh, it's the square root of 9, which is 3. Combine your like terms. Look at these two cancel out because minus plus, and we're left with 4 minus 3 equals 1. So we multiplied conjugate pairs where we had a rational plus an irrational and a rational minus an irrational, and when we multiply them we got a rational. That's nice because we use that to rationalize the denominator. Let's say we had a fraction that looked like this: 1 over 1 plus the square root of 2. Now I cannot just multiply by the square root of 2. We have to multiply by the conjugate pair. Okay, so we're going to multiply by 1 minus the square root of 2 over 1 minus the square root of 2. Okay. If we don't want to deal with the shortcut, FOIL always works. First is 1 times 1 minus the square root of 2 plus the square root of 2. Oh, those cancel each other out. Minus the square root of 2 squared, which is just 2, over 1 times that is just going to be that. So we've got 1 minus the square root of 2 over negative 1. Well, how do we deal with that? The negative comes up to the top, so we're going to change the sign. It's going to be negative times 1 minus the square root of 2. And we can make that negative 1 plus the square root of 2. Perfect. Next one. Conjugate pair. Multiply by it. 3 plus the square root of 5 over 3 plus the square root of 5. Okay. 3 times 3 is 9. So this is going to be 9 plus 3 square roots of 5 minus 3 square roots of 5. Oh, they cancel each other out. Minus the square root of 25, which is 5. Over, distribute. You do the distributive property here. 9 plus 3 square roots of 5. Okay, distribute. This is going to equal 9 plus 3 square roots of 5 all over 4. you can leave it like that. Or you could split it up to 9 over 4 plus 3/4 square root of 5. And I know I squeezed that. To solve some quadratics. Okay? To solve this, I would not expect you to do the factoring thing because we only have the x squared term, so that means we can solve by taking square roots. So we get the x squared by itself and then square root. So divide by 5. Divide by 5. We've got x squared equals 16. Take the square root of both sides. Now, when you're solving and you take the square root of anything, you have to remember that x equals positive or negative because 16 could be positive 4 times positive 4 or negative 4 times negative 4. Okay, you have to remember that. Okay, next one. Get the z squared by itself by adding 7 to both sides. So z squared equals 36. Take the square root. So z equals plus or minus 6 because positive 6 squared is 36 and negative 6 squared is 36. 16x squared minus 1 equals 0. Okay, here's one we can solve by taking square roots. You could factor it if you wanted to, since we know that this is a perfect square and so is that. But I wouldn't really expect you to. I'd expect you to isolate the x squared and then square root it. So add 1 to both sides. So 16x squared equals 1. Divide by 16. X squared equals 1 over 16. Square root. Okay, when we do that, this is the square root of 1 over the square root of 16, which both are perfect squares. How nice. So x equals plus or minus 1 over 4. And even if you factored, remember it's going to be 4x plus 1, 4x minus 1 equals 0, and you're going to get positive and negative 1/4. Okay, here's one. That's kind of fun. Divide by 3 on both sides. We're going to have x minus 2 squared equals 40 over 3. It doesn't go in evenly. I did that on purpose. Now we're going to square root both sides. Okay. So we're going to have x minus 2 equals plus or minus the square root of 40 over 3. We need to rationalize this denominator. Let's do it right now. Okay. When we do that, we're going to have, I'm going to need more space. We're going to have the square root of 40 times the square root of 3 over 3, right? Plus or minus. So do that. We're going to have the square root of 40 times 3 is 120 over 3, plus or minus. And that's going to equal, sorry I switched sides on you, x minus 2. Then we add 2 to both sides. So we're going to have 2 plus or minus the square root of 120 over 3 equals x. Is this really simplified? Does 120 have a perfect square factor? What about 4? 4 times 10. Okay, so we could actually simplify this even more, which yes, I expect you to do. 2 plus or minus the square root of 120, I know this is getting messy, equals the square root of 4 times the square root of 30, right? 30 doesn't have any perfect squares. Square root of 4 is going to be 2, square root of 30, and all that's over 3 still, equals x. Craziness. We'll do some more of these in class tomorrow.